Welcome to Man Does Tech, where I solve the problems you didn't even know you had.
You begin by confirming compatible hardware and installing the runtime and SDK. Plug in the headset, enable sensors, and run the device calibration routine. Once done, launch the example scene to verify tracking and spatial mapping are active. Make sure to grant camera and motion permissions. Without them, you won't get stable pose data. At this stage, you should see basic anchors and a point cloud. Save that scene state, so the next steps use a known good baseline for alignment and interaction testing. Now focus on the pieces that let virtual content lock to the real world. Fuse depth, visual, and IMU data to produce a robust spatial map and run loop closure if using SLAM. Once done, define world anchors so objects retain position across sessions. Simultaneously implement input handlers, raycasts for gaze or controller, gesture recognizers for hand tracking, and voice intents for commands, so the user can interact naturally. Test latency and drift, and iterate sensor fusion weights until finish by optimizing rendering and locking visuals to anchors. Apply occlusion meshes, match lighting, and composite depth, so virtual objects appear correctly behind real ones. Once done, run performance profiling to identify CPU or GPU bottlenecks and tune LOD, culling, and sampling rates to keep frame time stable. If things go wrong, check sensor calibration first. Recalibrate IMU and redo spatial mapping. Then verify anchor persistence and network latency. A single recalibration often resolves drift, jitter, or compositing errors. Try that before deeper debugging.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.